All right, yeah, so that's the topic for today. It's not really about securing APIs, but since this is an API conference, you can have to squeeze API in there somewhere. So that's what I did. Open Policy Agent is really more of a general policy agent. Of course, one of the better use cases for that is just as Remy talked about, to decouple authorization decisions. Decoupling, which is often called delegation in the authentication sphere, which is more decoupling in the authorization world. And I'm Anders, by the way, and I work for Bisnode. We're a data company. We sell smart data, smart people, and and I work as a developer advocate there. So in developers in 13 countries. Okay, so I think that's enough about me. Let's proceed to OPA and policies. So a good question might be there, what is a policy? I think Remy covered some of that, but let's reiterate anyway. So a policy pretty much is a set of rules. And it could be anything, like a business policy. Might be that you can't buy alcohol before you're 21, or you can't sell certain types of data to certain organizations or whatever. So any bundle of rules could be called a policy. And we use these policies to make decisions. So we can ask these policy engines, would this be okay? Given the policies, the rules we have here, is this okay or not? So that's kind of, for a programmer, for the programmers around here, it sounds pretty trivial. It's an if statement, like if age above 21 or so, then buy alcohol is fine, and if not, or else it's not. So we really need to decouple that. It's like that's usually like business logic, and I think for in many cases it doesn't make sense to decouple that. It's part of your application logic. But in some cases, and there are quite a lot of them as well, it does make sense. It could be that the complexities of these policies is tremendous. If you're working with like microservices or whatever, it doesn't make sense to have like 200 classes in a microservice working with policies and rules. It's not really a microservice then, is it? So complexities could be one thing. Another thing could, of course, be ownership. If you're in a big company or a bank or whatever, and you want this kind of either centralized control over policies, so you can at any time say this is a list of all of our policies. It's not scattered in 200 repos. Here's our policy repos, and that's all there is. And here's the tests to verify that. So that could be another use case or another motivation to use a policy engine. And there's a lot of use cases for them. Authorization is normally or it's one of the more common ones, where you just ask, is this okay or not? But a very common one for OPA, which I will be talking about some more, is infrastructure policies, where you could say cost control, where you can say like, I can scale up to this or this number of machines, but only under these conditions, or else we will break our budget, and so on. And you can do the same for configuration. So you say this is the min amount and this is the max amount, and the policy engine works with you to ensure those values. So, but the policy engine does not itself enforce decisions. That's up to you. So you ask it, is this a right or not, or is this within the boundaries? And it will tell you if it is or not. So it's like a friend next to you who you can ask. And of course, policies aren't of much use without the data. So I'll proceed to that in a bit. I think we covered many of the use cases for decoupling policies. You can have universal policies as well. So some policies are so common that doesn't make sense to repeat them in each of your application. If you have a policy that any access needs to be needs an access token. If you need an access token to access your API, for instance, that could be a policy which is shared and deployed with any app. So you can't really deploy an app without this requirement being fulfilled. So that's another use case for decoupling. And again, enabling centralized policy management. It doesn't force centralized policy management. You can still manage the policies within teams, for example, if you want to. And of course, you can also deploy policies separately from applications. Logging, auditing, another area, I think, makes a great case for decoupling of policies. Since you're probably going to want to know who did what and based on what data. And of course, you can do that in your apps as well, but you're probably going to do a lot of other logging in there as well. So there's a risk that it's all lost in the noise. Okay, so that was some general policy engine talk, an introduction to that. But I'm here today to talk about OPA, the Open Policy Agent, which is an open source policy agent. It's quite modern. It's I think it's like 4 years old, 3 to 4 years old or so. So it's rather new compared to the policy agents of old, which are often from, from like the early 2000s or so. It's an incubating project in the Cloud Native Computing Foundation, together with Kubernetes and Prometheus and many others. So it has kind of a good backing through that. And a lot of companies invested in these technologies are also invested in OPA. So policies are represented in the Rego language, which is a language only used by OPA, as far as I know. And I'll give you guys a demo of that in a bit. And all data is represented as JSON. That's makes it rather easy and familiar for most. It's very easy to deploy. Fits very well with this whole new DevOps mindset, which goes very well, of course, with the Cloud Native Computing Foundation. And there are many ways of deploying using OPA. It doesn't enforce organizational changes, such that many of these older, big enterprisey tools would say, like, okay, here's the policies. Where's your policy teams who will be managing this? OPA does not enforce any kind of organizational structure or such. It's all up to you. But of course, it's also a bit scarier because there's nobody going to tell you what to do. There is commercial support available, and it's used by several big companies. Okay, so a policy, again, it's not very useful without any data. You can say, sure, you can't buy alcohol if you're not 21, but if I don't know your age, I can't. This policy is useless. So we always need data, and data we can provide OPA in several forms. Probably the easier one is the input. Just send in your age, and I'll get a yes or no back. But it doesn't always scale as well, because there might be a lot of data needed for a decision to be made. So you can't always provide that with each and every request. So for that, you can either push data to OPA, which is kept in memory. You can set up a bundle server which OPA will query to get the data, or you can inside your policies go and pull the data from an external source. So there's that's the ways some different ways of providing data into OPA. And again, this is not mandated which way to do. It's just there are a lot of ways to do it. Okay, so Rego then is a high-level language for writing policies. It's inspired by Datalog, if anyone worked with that before. It's kind of like SQL. It's a declarative language. So you tell OPA what you want rather than exactly how to do it. It's very easy to read and write. Hope you will see that in a bit. And so many concepts and data types, etc., is easily recognizable. And the policies are really assertions. That's what you do. You say, given this or that, then either return true or false or return something else. And as any other declarative language, you can do, or OPA can optimize queries. And it's a pretty well-documented language at their official site. So a rule looks something like this. There's a body, which is, of course, inside of these brackets. And any rule is evaluated, like the name up there is going to be true if all the statements inside of the body evaluate to true. So if you provide an input here, and it says a resource, and the resource type would be deployments. And the team in the input would match the owned by attribute of this deployment. Then we would say allow. So that's a very simple rule, and you can express pretty clearly in a very few lines of code. And this last underscore within the brackets there is kind of like an include operator, or contains. So if any of the owned by values match the user team, then it's okay. And if only one or a few of these lines are true, then the rule evaluates to false. So running OPA, it's a self-contained single file. It's and you can call it either as a library if you write Go code, or you can run it as a service alongside your application. So you kind of whenever you're faced with a decision, then you can just query OPA and you get the result back from there. It's recommended that you run OPA on the same machine, either as a sidecar or on the same host, to minimize latency and such. But the beauty of OPA, to me, like the major selling point, if there can be such a thing for an open source project, is compared to other systems, how easy it is to test, and how easy you can test policies, how easy you can inject data and input, and try these policies out. So, and OPA ships with its own test system. So it's and you can test this entirely offline. So you can write policies on your flight, and you can test them right away. There's no like online requirement, even though OPA itself is a server. So before doing a quick demo, I'm just gonna talk a little bit about authorization policies, since that's what we're gonna demo. So there's a whole lot of different types of authorization models. RBAC, probably the most used one. If you're part of a group or you have a role, then you're good, or you can do certain actions based on that role. There's ABAC, which kind of says like, yeah, why would we want to limit that to only a role? We could use attributes from any source. And there's ACLs, which is more like the list. If you ever go to a nightclub and you're on the list, then you're in. That's like an ACL. Okay, so let's see if we can try this in practice then. It's the first time ever I do live coding, so let's try it out. Let's try and write a very, very simple policy. Let's call it policy rego. And let's create a policy test rego. And let's create a data file. So we have some data to test. But we can actually, before we even have data, we can do a simple policies. Not all policies require data. So first of all, we need to declare a package. So this is kind of programmers will know. Can you all see this, or good? So first of all, very simple policy is to set a default. And a very good first thing to do, since you probably do, if you don't know how to like interpret a question or something, you probably want to default to something, and it's probably going to be that you don't want to allow it. So we're gonna create a policy called allowed, and we're going to default that to false. So with only this simple policy, we can ask. We're going to write a test for that. We're just going to say test allow is false by default. And the syntax for that is going to look like this. So I'm not providing any data in. I'm not doing anything. I'm just checking what's the value of allow. And we're going to try it. Oh, sorry, they like my JSON file there. So let's do, because I guess it's not JSON. Okay, so do you see that? Great. And we can do the v flag as well to see that it's really that test being evaluated. So okay, that's a very simple policy, of course. It doesn't do much. Maybe we can extend it, and maybe we can make use of the data provided to us in the input. So let's match on input. Let's do RBAC here. It's very simplified RBAC. User role is admin. Of course, it's probably not going to look like this in a real case, real world scenario. This is probably going to be like a whole group of roles. But let's just say that a user can only have one role. And if it's admin, we're going to change the default value from false to true, since this rule would evaluate to true. So let's write a test for that. Allow if role admin. And now we're going to say allow with, and with is a keyword used for tests, where you can mock the input. So if you say, oh, sorry, with input user role is admin, or let's do it like this. And it's going to be role. We're going to say admin. Okay, so we now have a user, and the role is admin. And we should see what that says. And it still passes. So, of course, we should probably write a negative test here as well to say if role not admin. So we say Anders there. And we run the tests, and that failed. So why would that fail? Yeah, right. So that's the beauty of unit testing, right? You can have like fat fingers, you can be sloppy, but the test will always guide you in. And you help that as well. So okay, in just a few minutes, we're starting to work test-driven on our policies. And that's really the whole beauty of all this. You don't need to buy into this grandiose authorization vision or architecture. You can start like you're just hacking out, and it's really fun. And it's something people don't mention much when talking about authorization. Is it fun? Yeah, this is fun. So I hope that was my introduction for you to OPA, and thank you very much.